Welcome to calculus. Fractions will pop up when you least expect it. On this episode, Stevenson will demonstrate Let's go ahead and apply those concepts in those thinking maps. So let's make sure we understand our context. So let's read our problem. Number 9. The accompanying figure shows the velocity, v of f of t, of a particle moving on a coordinate line. Okay, so a coordinate line just implies that it's going to either move left or right or up and down. We now have 4 questions, or 4 question parts, and we have an example. Now, it is super important to know what you're looking at. This is the velocity function, so I highly recommend you write that big. You might be going, but Stevenson, I see it's v. Yes, but what we're about to do is we're going to diagram or annotate this graph. What I'm going to do is I'm going to mark 2 things about it. I want to know velocity and I want to know acceleration. Now remember, velocity is the direction and magnitude of your object. The first thing I want to do is note, where is velocity 0? Well, that's going to be an x-intercept right here. Velocity is 0 there. Velocity is 0 there. And velocity is actually 0 over this entire stretch right here. Now, if velocity is 0, that means acceleration is also 0. Next, let's look at the signs of velocity. Remember, the sign of velocity is super important depending on what you're looking at here. Because this is the velocity graph, all I have to do is look and see where is my graph. Is it above the x-axis or the horizontal axis, which is t, or is it below? So because this piece is above, I'm going to say the velocity is positive. In this piece right here, my velocity is negative because it's below the x-axis, or this horizontal axis. This piece right here, my velocity is negative because it's below this axis. This piece from here to here, my velocity is negative because it's below the horizontal axis. This piece right here, my velocity, so actually let's rewrite this because it's kind of in my way here. And I don't want to be confused. So this piece to here, the velocity is positive because it's above my horizontal axis. Right here, my velocity is positive because it is above the x-axis here. And again, this is still 0. Now let's go back through and chart the acceleration. Well, wait a minute, what's acceleration? Acceleration is the derivative of velocity. In other words, it's the slope of velocity. Look at this first piece here. What is the slope from here to here? Do you see it's negative? It's decreasing. So I say my acceleration is negative. Look from here to here. My acceleration is also negative because this is decreasing. Look from here to here. My acceleration is 0 because my slope is constant. See how it's a horizontal line? Slopes are constant, 0. What's my slope from here to here? Positive, it's increasing, so I say my acceleration is positive. From this piece to this piece, it's still increasing, my acceleration is positive. From this piece to this piece, my acceleration is negative. Now I have my velocity graph diagram. Now I'm actually going to start a question. A. When does the particle move forward, backwards, speed up, or slow down? When does the particle move forward? The direction it's moving is velocity. So if it's moving forward, because my object is moving on a coordinate line, so it's either moving up, down, left, or right, that doesn't matter necessarily. What we want to know, if it's moving forward, then velocity should be positive. So when is velocity positive? Well, it's positive from 0 to 1. It's positive from 5 to 7. You can write these answers in interval notation, or you can use inequality notation. Both suffice. Which one do you want to use? It's totally preference. Which one? When is it moving backwards? Well, if it's moving backwards, your velocity would be negative. So when is velocity negative? Well, according to my graph, I can see it's this entire piece down here. So I'm going to say from 1 to 5. So I'm writing these in two notations here. You do not have to do that. I'm just trying to illustrate the two ones. From this point on, I'll probably stick to inequalities. Next, when is it speeding up? Okay, so remember, speeding up and slowing down. Speeding up or slowing down. Okay, when your acceleration and velocity have the same sign, the object will speed up. And it doesn't matter what the sign is. All we care about is, do they match? Are they both positive or are they both negative? When is it speeding up here? Let's look. When are they the same sign? Okay, different. Here we go. They're the same right there. So when does that happen? From the interval from 1 to 2. All right, no, no, yes, right there. They're the same sign. When does that happen? 5 to 6. Now let's look at slowing down. Let's go back to our tree map. When is your object slowing down? Okay, we look at acceleration and velocity. So let's look down here though. When acceleration and velocity are different signs, the object slows down. Again, it doesn't matter. As long as, so if one's positive and one's negative, it's slowing down. When are they different signs? Here, so from 0 to 1, 3 to 5, 6 to 7. Let's move on to the second part, B. When is the particle's acceleration positive, negative, and 0? All right, so when is acceleration positive? Well, we already charted it, right? So when is acceleration positive? This entire interval from here to here, so that's 3 to 6. When is acceleration negative? Now, I should change how I'm writing this. I'm not going to introduce a new function. Acceleration is the derivative of velocity, right? So how's my velocity defined? As v. So I'm going to say this is v prime. I want to use the function names that are given to me. When is acceleration negative? So let's go back to our chart. It's, let's see, negative, negative. Okay, so this entire block here, so that's 0 to 2. Pause. Oh, and right there, that little piece right there from 6 to 7. And then it said, when is acceleration 0? All right, when is acceleration 0? We're looking at more than an instant here, so don't worry about these x-intercepts right there. We're looking for right here, so from 2 to 3. Looks like from 7 to 9. When does the particle move at its greatest speed? All right, let's go to our tree map. What is speed? Let's see. Speed is the absolute value of velocity regardless of direction. So what this means is we have to look at all of the values and think of them as absolute values. From there, what we want to look at is when are the times when it's the highest. So this spot right here looks like the highest. So we're going to we'll just write greatest speed. That happens when t, at the moment this timer is starting. It also looks like down here, remember, it doesn't matter that it's negative. What matters is the magnitude. And we don't have a scale here, but this does look like it possibly could be about the same as that one distance-wise. So we're going to say from the time interval from 2 to 3. D, when does the particle stand still for more than an instant? Okay, so 1 and 5 would be considered for an instant it's standing still. When is it not moving? An object is at rest when velocity is 0. But it said more than an instant. So I know it's tempting to say here and here at 1 and 5, but that would be an instant. More than an instant would be right here from 7 to 9.